Hi, welcome back. So today we're going to talk about how we get extrema. Now there's two types of maximum and minimum values. The first one that we talk about is what's called an absolute maximum and minimum. The other type we have is what's called relative, and we can describe them in two very simple ways. When we talk about the absolute maximum or the absolute minimum of a graph, we are looking at the values. We look only at the values, and that's f of x for us, the function itself. We look only at the values, and we look at what's the highest point, what's the lowest point. So if I take a look here, I want to find the absolute maximum for my function here. It's the highest point. Now this is a maximum, but it's not the absolute. This 812 is. If I want to find the absolute minimum, I'm looking for the lowest point. I have 5.3 is a low point, but down here, this -1, -2, that's the lowest point. So that's what we call absolute maximums and minimums. We look only at their values. Now, when we're talking about a relative maximum minimums, this is where we have to use our critical numbers. This involves critical numbers. Now, if you may remember, a critical number is where the slope is 0 or does not exist. The most important thing to do, remember, is these involve slope. These involve the slope, the derivative. Okay? Where an absolute is just the values, our relatives only involve the slope of the graph, where the slope is 0. So if I look at this graph here, I'm looking for a relative maximum or minimum. Right here my slope is 0. And it's a high point on the graph. So that's a relative maximum. Down here, this is a low point on the graph. Again, the slope is 0. My derivative is 0. That's a relative minimum. Now, a lot of times people wonder, well, why isn't this -1, -2 a relative minimum? Well, it is a minimum. But remember, we're looking at only where the slope is 0. There is no slope here. In other words, the derivative itself does not exist. So therefore it cannot be a relative maximum or minimum. But it can be the absolute maximum and minimum. So just kind of remember that. The absolute involves the function itself, just the values. The relatives involve the derivatives. Okay? But can a maximum be a relative? Absolutely. And that's always a good question. Can a relative be an absolute? Yeah. For example, let's look at a parabola right here. If you notice, the vertex, this is my absolute maximum. But it's also where the slope is 0. So it's also a relative maximum. So an absolute maximum and relative maximum can be the same. But only in cases like this, where it's not at an endpoint. Okay? So very easy to do. So another thing I just want to point out real quickly before we go, an absolute maximum minimum, we call these extreme values, or extrema. And so if we're talking about these, when we say what's the extrema of a function, we're looking at the absolute max and mins. And to find these, we use the extreme value theorem. And if you're wondering what that is, I have another video that I just posted on that, so you can take a look at that as well. But kind of going on the idea of what the absolute max or min, if we look back over here, and note down here, there's the extreme value theorem. You should have these notes with you. To find the absolute max or min, well, if I look here, I'm looking for the absolute max. Well, this is kind of a tricky one. There isn't any, just to tell you, because there's a hole there. Where's there an absolute minimum? Right here, this 2,1. Now notice, this 2,1, that's my absolute min, but it's also a relative minimum because it is a low point on the graph. It is where the slope is 0. Where's my absolute max here? There again, there's a hole there to your life. The value does not exist there. And where's the absolute min? That's just -1, -1. Now notice, this absolute min is not a relative minimum because the derivative does not exist at that endpoint right there. All right. Now here's a tough one. My absolute max is 3, 4. That's easy. My absolute min does not exist because they're both open holes. But here's the tricky one. Is this absolute max a relative max? Dun, 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 dun. Yes, this is a relative maximum because even though it's a cusp, the derivative does not exist here. Now, you might be thinking, but the derivative doesn't exist here. Why can't those include at the endpoints? Well, endpoints are different. At an endpoint, the derivative can't even try to exist. It goes against. Remember the derivative from the left and the derivative from the right? The derivative can't even try to exist here. Here, I am coming in from the left and the right. It's just a cusp. So, in that case right there, our absolute max is also our relative max. And this is a very important topic for us throughout the rest of the year. Okay? Now, I do go over the extreme value theorem in another video, so you can take a look at that if you have any questions. Okay? Bye.